The structure of benzene, the closest we came across to it was in 1866 when Kekule offered this structure of C6H6. But later on we decided this structure is too rigid and we disproved it, we didn't like it, and we said benzene should look like this, a hexagon with a ring structure, and the ring is indication of pi electrons are delocalizing and they produce this hybrid resonance. So benzene, it has this structure and Kekule structure was rejected. Now let's look at the four evidence that how we rejected, and you should also recall them and use them in your arguments. Two of those evidence are physical. If you recall, a double bond in alkene is shorter and stronger than a single bond in alkane. But in benzene, when we measure it, we see the bond length is somewhere between single and double bond. So if Kekule his structure was good, then this bond should have been 0.133 nanometers, and this one should be longer, 0.154. And we see this is not our evidence. When we take X-ray picture of that, we see all bonds are exactly the same, and they are 0.140 nanometers. So this is the first evidence that the Kekule structure is wrong, and it should look like this as benzene. The second physical evidence is lack of isomers. When we take 2-bromobenzene, we only see there are only 3 isomers, physical isomers. But if Kekule structure was true, then we should have seen the fourth one too, and you see this 2-dibromo we don't see, and we see the other one 2-dibromo. So we see it across a double bond, but not the single bond. So the fact that we don't have 4 isomers is another reason Kekule structure is wrong. So these are the two physical evidence. Now let's look at chemical evidence. The first chemical evidence comes from enthalpy of hydration. If you take cyclohexene, which has 1 double bond, and if you add hydrogen to it, it goes through electrophilic addition with nickel catalyst, and enthalpy that gets released is 120 kilojoules. So if Kekule's structure was true, when we add 3 hydrogen to it, we should produce 360 kilojoules. But on the other hand, every time we add 3 hydrogen to benzene, we see we produce only 210 kilojoules. So this is a strong evidence that Kekule structure is not true. Benzene releases less energy because of its stability due to the fact that it is a hybrid resonance. And that's very strong proof, chemical proof, that benzene should look like this and not Kekule structure. The last evidence, which is also chemical, is if we accept Kekule, then you have 3 double bonds, and it should go through typical addition reaction. For example, with bromine water, it should discolorize bromine and add bromine to the junction of carbons. But we see it goes through rather substitution. Only 1 hydrogen gets substituted with bromine, and the byproduct is the other hydrogen and bromine as hydrogen bromide. So the fact that the structure doesn't go through addition reaction is also strong chemical evidence that benzene should look like this ring structure here and not Kekule structure. So you should know all 4 evidence. They either show up in multiple choice or paper 2, and you have to sort of defend it and back it up.